Hello, my name is Andrew Bukowitz, and this is my lab report for the first lab for Intro Physics 2 at Georgia Tech. In this lab, I will be performing an experiment with two charge tapes. The main purpose of this lab is to use two charged pieces of tape to model the phenomenon of the transfer of electron between different surfaces. In this lab, we'll generate an estimate of the amount of charge transferred to a piece of tape and the amount of excess charge on that tape. Two key concepts on this lab are Coulomb's law and electric fields and electric forces. So Coulomb's law describes the attractions or interactions between two charged particles that are a set distance apart. Electric fields occur when occur due to a charged particle and how it impacts its environment. And electric forces are the forces felt by charged particles due to surrounding electric fields. Shown here are a few relevant formulae to the problem solving that we will do in this lab, starting with Coulomb's law, which I mentioned earlier, then going into a formula for the electric field at a point. Next, the force due to gravity, which will be important in calculating the force. And finally, the combination of how we relate electric field and electric force, and then just a few constants, including the gravitational constant and K. Shown to the right here is a diagram of the experiment that is conducted. In the top left, you can see a few constants measured from this experiment, including the distance between the two pieces of tape, the length of the tape B, the width of tape B, and the mass of that tape. A few assumptions that we will use in the experiment is treating both pieces of tape as having charge concentrated at the center as a single point charge, ignoring air resistance, and assuming that the U-tapes that are used to give these pieces of tape a charge has an evenly distributed charge. Shown here are excerpts of some of the glow script code that we used in this experiment. The first function shown is a function that gives the electric force and the gravitational force on tape B and prints it to the console. The second function is a function that gives the electric field on a point charge when we are given its charge. Shown on this slide is the output of our program. So in the image on the right, you can see the 2-point charges that were used to model the tapes in this experiment. The orange arrows indicate the electric forces that are applied from each point charge to the other. Towards the left side of the slide, you can see the mathematical outputs of our model, with the key one here being the charge of tape B. In this slide, we compare some of the numerical outputs from the last slide to hand calculations. Like I mentioned from the past slide, we are interested in calculating the magnitude of charge on the particle B, and when we calculate that by hand, that matches the computer output of negative 1.857 times 10 to the 9th coulombs. Additionally calculated here are the area of the tape, the number of atoms, and the number of electrons. Looking back at the assumptions we made earlier, the air resistance assumption ends up being irrelevant because the tape is stationary when they are interacting with one another, and it is important to treat the charge of the tapes as a point charge, and it is also important to assume the U-tapes had even amounts of charge that were distributed evenly. In this slide, we can see the two discussion questions that were posed to us for this experiment. Starting with the first one, if electrons had positive charge and protons had negative charge, there would be no real change to this experiment since it would sort of affect the fundamental fabric of the world around us, but also these two changes would counteract. Secondly, is it important to handle the charged tapes as little as possible so that if these tapes were to have a negative charge, it would not be dispersed among the object that it comes into contact with, or the object that it comes into contact with would not apply additional charge that would be dispersed over the tape. So it's just important to isolate the tapes so that they can retain their original charge. Thank you so much for watching.